At Cignition, we care about enabling every student to thrive in mathematics. We do that by bridging the gap between research advances in the neuroscience of learning and classroom practice, as well as home activity. Imagine it's the first day of a new school year, you're having your first math class, and the teacher says, register at this website, and this appears on your screen. Turns out that you can traverse around and you have a big island with varying terrain. As the school year progresses, you see that you spend some class time, homework time, and it turns out for most kids lots of their free time creatively building and crafting things on your island, such as buildings, farms, factories to manufacture things. But what you realize is that everything is intrinsically mathematical. Let's hear from a teacher at Catherine Smith School in San Jose.
I use Cignition in my class at least twice a week, dedicated time, and then if students finish early, then they can go on to their farm or their island and create more buildings and farms.
Cignition is a collaboration of neuroscientists, teachers, and game designers. The games encapsulate the best visual models for reinforcing the underlying mathematical concepts with every move. That's wrapped in a machine learning backend which can track mathematical performance and underlying cognitive capabilities, allowing us to adapt in the most effective way for each student. Let's take a look at how students learn fraction multiplication. Research tells us that the best model for that is an area model. So, the area model has now become a farm. This is a strategy game in which the players' fruit-bearing plants, these green ones, compete with weeds in order to take over the farm. With each move, the player must choose an area of the farm to irrigate without running out of water. For this next move, the farm is divided into two 7x3 grids. The player must compute the chosen area to water by multiplying the two fractional sides in order to manage the water supply. Let's watch a student's next move.
So how I strategize and how I know where to water my plants is I target and I try to heal up the lower plants. For example, this one right here, this one health, and orange is right there. So I'm trying to protect it. So I'm trying to heal this one health guy. So then he is higher, and then so orange can't kill him easily. And then I'm gonna do this. So then I just.
So, what just happened? First of all, one of the key neuroscientific principles of learning is that the more brain areas you stimulate as you're learning a concept, the more richer representation your brain will develop, which makes it easier to recall in the future. We just watched this student strategize about what part of his farm he wanted to irrigate. He used motor and visuospatial skills to choose that area and then could immediately see the numerical representation of that choice. Then he can see the equation that he has to solve. And he needs to make an estimate to make sure he'll have enough water to irrigate that much of the field. He solves the equation and then makes his move. So many different brain areas were involved all around the process of operating with the concepts behind fraction multiplication. Next, let's look at an example of learning fraction addition based on fraction bars and number lines in the guise of rows of bricks to create a building. This student has been playing for a while, so the game is trying to challenge him with more difficult problems of unlike denominators. Let's take a look.
And so I'm trying to work my way up onto this third one right here, if possible. So put this fraction down. There we go. So this one has a denominator of 10. This one has a denominator of 4. So I'm trying to find the lowest one, which is 20, which I know of. So 4 times 5, 2 times 10 equals 20. So there. Put it down. I just click that once, and then I need the remaining 4. So 4/20ths.
The player just found a common denominator and added the bricks together. His result was a fraction greater than 1, so he converted it to a mixed number because he felt that would make his subtraction step easier. Kids learn many types of transformations throughout their math education. For every transformation we teach, such as the transformation from improper fractions to mixed numbers, we intentionally put kids in situations where they get to think about and choose which transformation to use to make their problems easier. That helps develop a core problem-solving skill. Now, let's watch him figure out the third brick to fill the row.
And I don't have a 20 denominator here, but then I try to like find the fraction and I multiply it to see if it has a denominator of 20 and the amount I need to remain it. So what I like to do is I need to find a factor of 20. So I need 4/20ths. Right here, 5 times 4 equals 20, and 1 times 4 equals 4. So then this fraction must match.
Now, let's see what the teacher sees while the class is busy crafting things. This is an example from fraction addition. For every topic we teach, we determine the complete sequence of conceptual leaps required for mastery. This chart shows every student's level of mastery of each topic. Here we see one student struggling with a particular concept. This gives the teacher the information they need to help this student. The teacher can also click on any particular student to get more detailed information about both their conceptual understanding and their procedural fluency. When you put all this together, you have very engaged students, a deeper conceptual understanding, more effective learning, and more effective teaching given the detailed, actionable information that the teacher can now access.